You know, if we looked at some properties, real numbers like the commutative property, the commutative property of addition or multiplication says you can just kind of move things around and it's still equivalent, right? The associative property, that was the one where you can group things, you know, any way you like, if it's all adding or it's all multiplying, right? And then we had the distributive property that justifies certain things, okay? So we have a couple more properties here. They're properties of equality. You know how we're solving equations, right? And sometimes you add the same thing to both sides of the equation, okay? That's called the addition property of equality, right? You know how sometimes you multiply both sides of the equation by something? That's justified by the multiplication property of equality, or POE. And so that's what they spell out here, right? Properties of equality. And I will say, when you get into geometry next year and you start doing some proofs, you'll have to remember these and use them, okay, to justify certain things in geometric proofs, which kids love, by the way, I think. I don't know. Anyway, I like it. You don't even know, so moot point. So anyway, this is how they laid out. If A and B are equal, right, you could take A plus C equals B plus C, right? You're going to add C to both sides. And notice there isn't one for subtracting or division, right? Why? Because you can think of addition as well. No. Adding A. You can think of you can think of subtraction as adding a what? What? A negative. You know? Instead of, 10 minus 5, you could rewrite it as 10 plus negative 5. And so it's still addition, right? And division is really multiplying by a what? Fraction. Instead of dividing by 3, you can multiply by 1/3, right? So that way the properties hold. Okay. So here's a bunch of equations, and we're going to solve them like we've been solving them, right? But all these things we do to solve them are justified with some certain property. And some of the Regents questions will ask you, they'll have stuff like this, and they'll ask you to write the property that justifies each step, right? So we're going to do that, okay? So we have this 2x plus 9 equals 21. And here's the first step. And then, again, they do it a little differently, right? They're subtracting 9 from both sides, right? And I go down below and do minus 9 below, right? But this is the same thing, okay? So what property of equality of these two that we just learned applies here? It's the addition, right? Remember, subtraction is like adding a negative. So this is justified, yepper. Do that. 10, 10, 10. And we can abbreviate. Addition, POE, property of equality. Okay? So everything we do to solve equations is justified with some property. Now, what about this next step here? Yeah, really, aren't they now dividing both sides by 2? But they're writing it as what? Multiplying by a half. So what property do we have here? So the multiplication, what? We can call it POE, property of equality. Okay? Keeps both sides of the equal sign equal, right? Are you with me so far? Yeah, not hard. So now down here, we're going to have to pull in some of the ones we learned before, okay? So they have this equation here, right? Got stuff in parentheses. And in this first step, they took this original equation up here and did what? What did they do to get that step 1? So they used the distributive property, right? Okay? So, oh, I don't like that. You see that? Look at that. They have a plus minus right together. That is another infantile. It demonstrates a real lack of any mathematical sophistication. If you're going to do plus minus, you do it like this. Okay? They do it, yeah, boy, they did it here too. Okay? All right, I'll get to that fish and fry it when I get there. Okay? So anyway, they kind of moved this negative 2x over here, the other thing over there. What property justifies that? The one that says you can move things around. Not what? Commutative, right? To commute, move, right? So the, of what? No. It's either addition or multiplication. Good, addition. Right? Commutative property of addition. Okay. Now let's think about this one here. Look at this next step. Look at this next step. So they took this here and made it into that. Okay, all right. Oh, well, let me ask you this. Let me ask you this. If I was to go from this step right here and wanted to get back up to this step, what would I do here? You mean, well, huh? I would distribute, right? So what property? So they just went the other way. But it's still the distributed property, just backwards. So we still justify it with the distributed property. In other words, they factored, didn't they? Right? Didn't they take out the greatest common factor? Okay. So all they did was do the distribute. Remember, because if we distribute here, this is what we get. Okay. So they did it backwards, but we still call it the distributive, whoops, property. This stupid pen color stuff there. Blue. Sounded like I cracked the screen. All right. It sounded like glass, but it didn't. I think it was just a pen. Okay. All right then. Now, then what do they do here? Oh, so then they just kind of, yeah, they don't want to put a step there, right? X minus 8, yep. Yeah, yep. Oh, look at this. God, it's perfect. That should be like that. Okay. All right, so how do they get from here down to here? See where the 4x is here now? Where was it? There, on the right side of the equal sign. Right? Now it's over here on the left side. What did they do? No. You can't reassociate across equal signs.
They put the like they were like.
How are we getting this 4x away from this side and over to this side of the equal sign? Subtract it from both sides, which is what property? Yeah, it's the addition property of equality, right? Where you add or subtract things to both sides of an equation, right? Okay, we just did that. Okay. So now they went from step 4 to step 5. Take a look at it. Tell me what property would justify that. Look how things changed between step 4 and step 5. It's usually a step that we don't do, right? What is the property? What did they use here? Commutative, associative, distributive, addition POE, multiplication POE. Look at the difference between step 4 and step 5. Say what? Say it again. Say that again. Well, they changed positions, didn't they? What property allows you to change positions? To move from one position to another. Associative means to stay in a position, but you group them. Commutative property, there we go. Of what? Yes. Don't forget to put that in there. Okay. Now let's look at the difference between step 5 and 6. Should look a little familiar. It's very recently familiar between step 5 and step 6. They changed this thing to that thing. What? Distributive property just backwards, right? Remember? So it's still the distributive property, even though they use it backwards to factor. Okay? And the very last step here. So they went from this negative 3x equals 15, and they simplified everything out, right? And what they do to both sides here? Divided by negative 3. What property? Multiplication. Property. Why multiplication? Because dividing is like multiplying by a fraction. They could have multiplied by negative 1/3, right? So the multiplication property of equality. Right? Start to get a sense of that? Okay, let's go to the next page. All right, same kind of thing. Let's see if you guys can work through this. So we have this equation up here, a bunch of parentheses, right? And if you look at step 1, well, they gave it to you. How did they get from the original equation to step 1 here? Distributive property. Good, they wrote it. Yeah, you can read. Outstanding. Okay. And then what did they do? Look at the difference between step 1 and step 2. What property? No, hold on. What else? No. Look, just to be clear, guys, commutative, associative, distributive, they cannot be applied across equal signs. Okay? So that's why we have these other two that take it. What is it? Addition. Probably what? POE, right? Look, they added negative 8 to both sides, right? Subtracted it. So it's the addition, POE. Okay? And now let's look between step 2 and step 3. Okay, you guys are getting it now. That part to that part, right? It's backwards, but again, they use the distributive property, right? For yeah, that's what it's lined up to. And for some reason, they gave you the next one, so they simplified that to this, right? And yeah, so they're just they're subtracting 2x from both sides, so addition, property of equality. And then how about this last step here? Well, they went from like this here to that. It's not really the last step. This guy just moved here. Commutative property, yes. Okay? So like, when you're doing your homework, you probably should have those notes in front of you so you remember what property you're looking at. Okay. Look at this here, guys. Look at the final result of solving that equation, by the way. Yeah. Yeah. Look at the final result of solving this equation. There's no x left, right? And yeah, negative 11 does not equal 0, right? It does not equal 0. I think they're going to ask about that down here. So the final line of this is strange statement. Negative 11 equals 0. Is that a true statement? No, right? Because negative 11 does not equal 0, right? What do you think that tells you about the solutions to that particular equation? Huh? There's no x value that'll make it true, right? So it looks like we could plug in any value of x that we want, and it'll never make both sides the same, right? So what do we say? Are there any solutions? Okay? It has no solutions. Okay? And we have a word for that in math. When an equation has no solutions, we call it inconsistent. Inconsistent. Okay? It's an inconsistent equation. It has no solutions. Right? A real simple equation that would have no solutions, just real quick, so you get a sense of it. What if I had this x equals x plus 5? Just think about that. Would that have any value of x that would make it true? Any number? What number would make that true? So you take that number and say it's equal to the very same number when adding 5 to it. Is there any number that would make that true? No, so that would be an inconsistent equation, right? I'll just, I don't know. Parenthetically, there you go. All right, so here's another equation. 7x plus 2 times the quantity x plus 5 equals 9x plus 10. They want to show that x equals negative 5 and 2 are both solutions. So you know how to do that, right? So you take the negative 5 and do what? Plug it in and see if it makes it true. So let's do that. So 7 times negative 5 plus 2 times negative 5 plus 5 needs to equal 9 times negative 5 plus 10. So let's start simplifying this. This should be simple. Negative 35, right? What's negative 5 plus 5? 0. 2 times 0 is what? Okay. And then, so that's gone, right? So equals negative 45, right? What's negative 45 plus 10? Negative 35. 0. Negative 45 plus 10. Right? Okay. You guys got to practice thinking about the left side of the number line. All right. And what about 2? Yeah, so 7 times 2 plus 2 times 2 plus 5 equals 9 times 2 plus 10, right? Hurry up here. So this will be 14 plus, what's 2 and 5? 7, 14, right? 2 times 7 is 14 equals 9 times 2 is what? 18 plus 10. What's 14 and 14? Equals 28. That made it true. There's 2 values of x that made it true. Okay? Why don't we go through and solve this equation like we do and see what happens then? Okay? So solve the equation by nipping, yeah, okay, we know how to solve them, right? 2.4. Believe it? Okay, feel better. So let's take the, what was it? 7x, let's just not rewrite, let's take it and distribute it, right? So if we're going to solve it, our first step would be 7x plus, distribute the 2. What do we get? 2x plus 10 equals 9x plus 10, right? What should we do over here on the left? Wish there was more room here. Let's get, so what do we get over here? 9x plus 10 equals 9x plus 10.
You don't have to solve it for that.
Well, let's go through. Let's get all the 9x's. So subtract 9x here. Right? What's that leave us with? 10 equals 10. The variable's gone. How often does 10 equal 10? Does 10 equal 10? Does 10 always equal 10? It does, okay? So what would you say about the solutions for this particular equation? How many are there? Huh? Yeah, any value, any number I put in for x, would it make both sides true? Right? So this is true for all equations, right? So it has, or all x's, infinite solutions. Any x you plug in there will make it true. Okay? It's true for all values of x. So the one up top equation before we said was inconsistent. Okay? This equation, when you get an infinite number of solutions, is called an identity. Okay? That's called an identity equation. Probably the simplest example of it would be the equation x equals x. Right? It's an identity equation. And then they want us to test. You get the, I'm not going to waste time with C. Plugging anything in there will cause it to be true. Okay? All right. Well, we're not going to have time to get to the Regis questions, but you can do the homework. Okay? And somebody remind me tomorrow we have to do the Regis questions here. Okay? Okay.